Good day. This is the Ner Ogle channel. Just call me Sir June for short. I'm your teacher in Precalculus from senior high school in Lagos City. Last time we have discussed about conics and how we can get those four shapes that could be useful in architecture and other engineering matters. The first one, we have circle, ellipse, parabola, and hyperbola. Now today we are going to discuss about circle and how we are going to define and find its standard equation, general equation, and some sample problems in getting the standard equation of the circle. Okay, let us see here the illustration. Okay, I know you have the prior knowledge about circle in your junior high school and elementary years. Okay, we have to discuss the parts of a circle. The first part is the diameter. The diameter is the longest chord or the longest line that passes through the center from a certain point to another point in the circumference of the circle. Next is the circumference, or sometimes you call it the perimeter of the circle. We know that the formula of the circumference of the circle is C for circumference equals to 2 pi r. And pi has an equivalent of 3.1416. But we just limit to 4 decimal places because this is indefinite decimal places. Okay. The circumference of the circle is this one, the perimeter encircling the circle. Okay. Next, we have the radius. The radius is half the diameter. Okay. From the center to a certain or at any point in the circumference of the circle. Okay, that's the radius. Another is chord. The chord is any line that passes from any point of the circumference of the circle. And we know that the longest chord is the diameter. And most of my colleagues say that the circle has only two parts, but I have discussed a lot of parts here. They have said the inside and the outside. That's the sides of the circle. I know that the circle has no sides. They just jokingly say the inside and the outside. Inside of the circle and outside of the circle. Okay, next we know that the area is A is equals to pi r squared. Okay. Why do we study circle? Because circle is all around us. Like the CD, this is a circle. This plate, this tape, this tape, and many other things. We cannot travel without circle because wheels of the car are circles, including the wheels of the plane. So, circle is very important to us. But how are we going to define the circle using the equation? The standard equation and the general equation. First, let us tackle the general equation. The general equation of the conics is we have here the coefficient and the value of the x and y. We have a ax squared plus by squared plus cx plus dy plus e is equals to 0. That is for the conic system. But in circle, since from the center any line is equidistant, meaning equal distances, okay, so if you are just like the clock, it has an equal distances, we say that A is equals to B, the coefficient. Okay. So therefore, we can say that ax squared plus ay squared plus cx plus dy plus e is equals to 0. So we can identify clearly from the general equation that that is a circle. For example, if we have here two x squared plus 2y squared is equals to 0. This is a circle. Okay. Next is we are going to discuss how are we going to get the standard equation of the circle. The standard equation of the circle is we are going to set a certain point P named x and y, and the center C from the H. I use it here H and K. H here is the x and K here is the y. But actually we can create a triangle, a right triangle, right circular triangle, and we can derive through Pythagorean theorem. Okay, we have here using Pythagorean Pythagoras. Okay, ancient mathematician. Okay, we have here r square. We have here is equivalent to x square plus y square. The r here is the hypotenuse, the x square is the horizontal line, and the y square is the vertical line. Okay. Another thing is, how about if it is not at the center, h and k? So we are going to use the distance formula. Still remember, if we are going to find the distance from the point C to point P, we have here point P, C, and point C is equivalent to R. So the distance between point P and C is equivalent to R. We say that R is equals to, so recall your distance formula. We have here square root of x minus h square plus y minus k quantity square. So that is the distance formula. Or you say in your junior years, x of 2, quantity x of 2 minus x of 1 squared plus quantity y of 2 minus y of 1 squared. Okay. If we are going to delete this square root, transform it into the radius, we have here r squared is equals to x minus h square plus y minus k square. So therefore, this is the standard equation of a circle at point h and k. Okay. Standard equation at point C, H, and K. Meaning, the center is not at the origin. If we are going to get the standard equation at origin, we have to satisfy C, 0 and 0. The value of H and K are zeros. We're just going to substitute. And we will go back with the Pythagorean formula. Okay, we have here r square is equals to quantity x minus h minus 0, if we are going to substitute, square plus y minus 0 square. So therefore, this is equivalent to r square is equals to x square plus y square. So this is center at origin. Okay. So this is the standard equation. So we have two. At any point, center at any point C, quantity h and k, and center at origin. Actually, this is just a formula from the Pythagorean theorem. Example, finding the equation of a circle at origin. We have here, example, r is equals to 5 and at origin. Okay, when you say at origin, so meaning the center is at 0, 0. Okay, we are going to satisfy this formula. We have here, just copy the formula. R is equals to 5 square equals x square plus y square. Okay, we are going to write it using the general equation form. X square plus y square is equals to 5 squared is 25. So this is the standard equation of the circle at origin And we can also